So we observe that the accuracy of this model is 94.44%, right? And looks like a good training. And now, what if I want to see, say, how the training has happened and what are the weights? I want to visualize the weights. That's my next objective. And it is possible to view the trained weights as well. Okay, so let's go ahead with that. Now, let me go to the second layer, and that's a convolutional 2D layer. So first layer is image input and second layer, right? So here I want to visualize the weights. Okay, so let me go for the name. Name is equal to, in the trained network, I think I have given the name as net itself. Let me check. Yeah, it's a net. So net dot, you can specify the layers. Oh, sorry, not layer. Okay, net dot layers. You can specify that I want to go to the second layer, and I think I can show you here. So when I open the net, right? So it's a network. You see layers. So net dot layers will be this. So you can see net dot layers. I'm talking about the second layer, that is a convolutional layer. Okay, in which I can try to find out a name as dot name. So if you click on this, you see net dot layers of 2 comma 1, doesn't matter, dot name. This is what I'm talking about. So dot name, that is the name of the layer. Let me define channels, number of channels, right, which I want to visualize, starting from 1 to 25. Okay, now let me create I is equal to, you see, it's a I want to visualize the weights in the form of image. Okay, so to convert the weights into the image format, there is a command, deep. You see, there's a command called deep dream image. I have to specify the following things, which is the network, so that's a net, followed by what is the name you want to see, and the number of channels. Let me, all right, so let's just go with this. So let me see whether I can add some more points. So actually, there are so many things we can specify, right? Let's run this as it is, and then we'll see. Okay, so I will not go with any other things, specification. So I created an I. Now I'll call a figure. Then I is equal to, I'm going to convert, see, there are 25 images I'm trying to plot. Okay, so that is, I have to convert these eyes, which is a deep dream image. I want to convert into I am tile. So yeah, so combine multiple image frames into a single rectangular tile. You can see that, right? So that's what it's doing. So I am tile, right? Converting several pieces of images into a single tile. Okay, so I have to say which is my image handle, that is I. Then maybe I can also specify what is the size, but I'll not do that as of now. Let's keep it as simple as possible. Okay, so this is uh, I. Oh, sorry, it's automatically taking that into. Okay, so that is I. Then I'll call I am show of this I. Okay, let's see how this runs, and let's make modifications after that. Once we see this, it's going to take some time because again it has to bring all the values from uh, the network to weight. It has to bring them all over. Okay, so it takes some time. Again, it will run on a GPU if possible. So you can see automatically it is actually performing the verbose as well. All right, let's see. Here we can see the changes made are like this. I moved to the sixth layer because I want to visualize the sixth layer's weight. Okay, that's another convolutional 2D layer. So there are 64 different filters present over there, but I gave just 25 now just to see how it comes up. And now since it is much deeper layer and this layer is located deeper into the neural network inside the deep learning, sorry, deep neural network, I am expecting more features. Okay, more and more features related to the whatever what you call graph. Okay, whatever photos we have, whatever data set we have, I'm expecting more details to be present over here. That's the first thing. So that's why sixth layer, the name is layer six, number six. Channels I gave just 25. If it works, then I'll extend to 64 and see what happens. All right, so that's my objective. Other than that, we have not done any changes. Okay, only the thumbnail says I felt this was too big, right? 512 into 512. So I slightly reduced it to half of that, 256. Now you see, right? I think it's visible, right? Uh, just now we got this thing, right? You can see that, right? This the details that are present inside our filters are slightly more. There is some more details, like maybe it is relating itself into what you call as I can see the patches right in each of this inside each of these, right? I can see maybe it represents somewhat something like our blood cells, right? Maybe the texture, right? Various parameters are right represented over here. Definitely I want to visualize all the 64. Let us see, and let's see what's going to happen. Right, I'll try to make this easier. This was just 25, right? Let's make it 64. Let me save this and run this section, and let's see what's going to happen. Okay, once again it will iterate all over again for the 50 iterations. Then it will show the plot. I think we have the results. So as you can see, it's plotting 6, 7, 8 into 8. So all the 64, right? So again, we can see the various types of patterns possible over here, right? You can see, right, the orientation is, it's actually, right, tilted to the left, right? So I can also see the horizontal patterns over here, right? And see various textures. This is something like a blood cell, right? This is another type. The various colors, etc. Right? We can see the plain color over here, etc. Right? So, so visualization is also pretty important whenever we are going to implement something using this kind of technique.